Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
All right, welcome to the latest episode of Lunch with Tech Leaders. My name is Ray Welker, and I'll be your host today. Joining me is our software and data consultant, Tom Kowalski. Say hi.
Hello. Howdy.
And last but not least, we have our technology consultant, Joel Coleman.
Hey there, Ray. Thanks for having me. Just a quick note, if any of the listeners have any questions or want a little bit of a topic to be covered, go ahead and throw it right there in the chat, and I'll be sure to interject and make sure we get it covered. So thank you so much.
And Tom, do you want to give our guest an introduction as well?
Yeah. So today, talking a little bit about the infrastructure as code and the tools. And to do that, we brought on Tommy Francis. Tommy. Why don't you go ahead and introduce yourself?
Hi, I'm Tommy Francis, or Tom Francis, but today Tommy Francis. I'm a cloud architect, solutions architect, currently at Small CDR, which is a health data fabric company. But my passion is very much been around automating infrastructure for a number of years. So I started off my career as a developer support for Microsoft in the UK way back in the 90s. I transitioned to like an infrastructure role because I was interested in stuff. I like to learn. I'm interested in things, right? And then when the whole cloud and infrastructure as code type technologies started coming around, then that felt like the perfect meld of those old dusty developer skills and my interest in infrastructure. So since then, I've been very keen to learn and use infrastructure as code where possible and where appropriate.
Awesome.
Yeah, I kind of have the same story too, right? Starting off more as a developer and then slowly gravitating more to infrastructure. So yeah, infrastructure as code was just, a natural fit, and it just made a lot of sense. Yeah. Same with like serverless in the same sense. It was like, yes, this is where we should be going.
Yeah, you have a lot of experience, Tom K, with serverless, right? Serverless framework.
Yes. Yeah.
Yeah. Excellent. Well, today we're going to be covering infrastructure as code as a whole. Wanted to touch on a few of the tools there. CloudFormation, Terraform, AWS CDK, serverless framework. We wanted to touch on Helm as well for Kubernetes. I know our guest here, he has quite a bit of experience when it comes to Helm, and wanted to touch on that here. So we got a packed agenda today, so grab your lunch, maybe even a notepad, and buckle up. So CloudFormation, I feel like that's kind of a natural starting point. Maybe one of the oldest infrastructure as code tools, specifically, for AWS. What do you think really started to maybe shift the focus in maybe in your experience, Tommy, for the use of infrastructure as code? Did you have to present any sort of like maybe business use case, or was it maybe adopted at a higher level originally?
So we had to adopt this in a very organic manner. And I think I just made that term up. But what I mean by that is I initially, again, going back to the earlier automations. So with Chef, I created this Chef recipe that would build out our web farm completely, including all of the virtual hosts for the different business units. And it was neat. It seemed like magic at the time, but couldn't get any buy-in because it needed root access, and that's a big no-no. So it was like just myself trying to bring these efficiencies. So that didn't really work. What really changed that was our introduction to like DevOps. So we started, some of the business teams wanted to follow an agile approach and use Jira. So we went down that path of installing that. and with Bamboo as well. And I started automating a lot of the manual processes we did using that. And that started getting the visibility that, yes, automated processes they do save time, they're repeatable, and they are actually reliable despite the fears that people have of running these code-based things for tasks that were typically manual. And it became clear after a while that the code makes less mistakes than the fingers, right? So if you're repeating a task endlessly, like doing a deployment or whatever it is, deployment to Tomcat or WebLogic, fingers make mistakes. Code can make mistakes as well, but it's a mistake that's made once when you're coding it. You may find that mistake, and then that mistake isn't going to happen again, right? So you get that repeatability. So there is that curve of where the organization has to gain confidence that infrastructure as code is a suitable technology to use. But this was earlier in infrastructure as code days, though now it's a buzzword, so everyone's like, yes, we have to have it. But back then, we had to go through this, like, trying to get the organization to get some buy-in without having any external experts come in. Because if we had access to, some large external entity that would say, this is how you do it, then the business would probably jump on that. But when it's an internal person who's passionate about following these new technologies and the current efficient ways of doing things, that can be a bit harder to get the buy-in on that. So you got to really show it in use, which you can't automate everything at once either. So you've got to find the tiny building blocks, show that automation works, and build the confidence. And that ultimately you get to the point where they realize we should be doing this to as much as we can.
I think you brought up a really fascinating point in that, maybe whenever you're trying to drive change internally, it can be a little more difficult to present a case than if you had maybe an outside company saying you needed to use, XYZ tool. I guess kind of that's regardless of the tool you choose, the same concepts still apply. So we talked about four different tools, essentially we wanted to maybe cover, but I'd say regardless of the tool that you use, still all of these best practices play. It's kind of a security, source controlled related way of configuring your infrastructure. It can be immutable. You're writing your templates once or your code once, and you can apply it to various, accounts or, perhaps even, multi-cloud strategy. I kind of wanted to touch on CloudFormation specifically. I guess, that would be if we're talking about AWS native services itself, but so many of these other tools branch outside of AWS. So I guess in your case, Tommy, were you guys AWS centric to begin with, or did you kind of have a local or hybrid approach?
I guess AWS kind of landed in my plate personally. So I had been interested in AWS for years, but I hadn't done more than spun up an EC2 instance. I thought that was it, right? I was like, oh, you can spin up an instance. Isn't that cool? Then we actually acquired a company that they were fully utilizing AWS. So I took that as a initiative point to self-study AWS more. I did the A Cloud Guru courses myself, and my head exploded with glee because it's just, wow, it's so much more than just spinning up servers when you need them, as we all know. From there on, we became an AWS shop because of that acquisition. So I heavily involved myself with that team that came in. And so that part of the business was definitely AWS. Once we started getting some basic AWS knowledge, I'd done my CloudFormation by that point. We started, sorry, that was incorrect. Once we'd got we'd onboarded the company, we got involved with them, we started looking at moving other workloads to AWS. And that's where I started my CloudFormation journey. We had to, I forget now, it was a while ago, but had to do some fairly complicated cloud formation. It was actually, we were installing a proprietary application, and the ask was to put it in AWS. So this was like Windows, an application running on Windows. It's kind of a manual install, but I have a really strong conviction for automating things. I really want to get away from manually doing things wherever possible. So typically installing this application on Windows is a very manual task, but I took it on myself to automate it, primarily using CloudFormation. So I had to do some fairly complicated in there. I think it was called intrinsic functions. I can't remember. It's been a while ago since I've actually had my hands dirty directly in CloudFormation. But that was another confidence builder, right, for the organization. The effort up front to automate that there was a lot of effort. But then at the end of that, we could like boom, 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 throw out these environments exactly the same repeatedly. And then they really saw the value in that, because typically before that, even with the cloud, to rebuild that would have been 2 or 3 weeks. Now, after this, I think it was 45 minutes to install a complete environment. So the value of IaC really, really took a hold there.
So was that organization that you acquired, were they already using cloud formation, or did you just start, taking it upon yourself when you started to migrate workloads over to start learning CloudFormation? And when was it?
They were using CloudFormation for their existing workloads. They had ECS-based workload.
Okay.
And I didn't, at that point, I didn't know about Terraform. So I learned about the native tools that were available. This was before we had CDK. I think SAM was just coming around the corner.
Okay.
Service, maybe CDK was a thing, but it wasn't a well-known thing yet.
Yeah.
So I had to get right into the CloudFormation, and there was some. I think I had CloudFormation that avoid. So there's always a problem. You know what? I don't want to digress. I was going to talk about provisioning the database and the users inside the database and how I did that from CloudFormation. But if you want to go down there, I can. But otherwise, it's a bit of a deep rabbit hole. And it's what directly related to.
So you started off with CloudFormation. What brought you to the other tools? I started mentioning what gravitated, which tools, and what did you gravitate towards and why?
Right. So at a previous organization, our AWS journey started with the acquisition, and at the same time, around the same time, we started a project, an endeavor. I forget the word. There's a word for it, to create some new AWS accounts for other parts of the business, mostly for the data lake type stuff. So there was this data lake initiative. Initiative is the word I was looking for. There was a data lake initiative, and we got a third-party vendor in to help us build out the infrastructure for that. They did use code for the infrastructure, but they basically had a bunch of Python scripts running Boto directly. So that was just imperative implementation of the AWS API. There wasn't any infrastructure as code so much. It's just scripting manual processes.
Persistent state.
Nothing like that. Nothing like that. So it was like more like the traditional scripts we were running for years on other processes. Very like the old mentality of how to code infrastructure. After disagreements, I guess, we actually got directly involved with AWS and a different company that was working with them, another provider. And we had a great relationship with them. And then we built our first landing zone. And that was the first one. Yeah, when they came in, there was this big discussion of CloudFormation versus Terraform. And I remember being there for the meeting. And there was the discussions of like, well, CloudFormation is obviously AWS specific, right? And Terraform, the message that trickles up the organization hierarchy is that it's multi-cloud. Now, the language constructs, if you learn it on AWS, that's going to work anywhere. So once you learn HCL, you've learned HCL, except for the new stuff they add as it develops. But if you write stuff in Terraform for AWS, there's no. I guess you could write it in the way that it's multi-cloud, but typically, if you write resources if you write a Terraform project that's just for AWS, you're not going to be able to pick that up and put it on another cloud, because all of the providers' resources, it's for AWS. So, the technology is multi-cloud, but nothing you write is necessarily multi-cloud. I think the message that the management had was that, no, it's multi-cloud, so we do it once and it's usable everywhere. So we ended up going with Terraform. For me, I had got my hands dirty with CloudFormation. This was a great experience to realistically get my hands dirty with Terraform as well. So we went down that path. So then on take 3 for our third landing zone, we actually went to Control Tower, which is all powered by CloudFormation again under the hood. So we were a bit of a mix, but the main push to go to Terraform was for the multi-cloud, and it was a push from above.
Yeah.
So did you use any?
Go ahead, Tom.
Sorry, I keep going, but yeah. So did you use CDK at all, or any other tools, or did you just everything from then on was Terraform? Or I have played with CDK, but I haven't used CDK in any professional environment yet, unfortunately. I do love the look of it because the whole imperative versus declarative thing it's very interesting, right? So you've got the likes of CloudFormation and Terraform, which are basically declarative. You're defining the state you want, but sometimes the state you want is different in one environment to the other, and that's tricky to express in a declarative language, right? So they've added the constructs, they're very clunky. They're not like a regular language. So you've got the looping, you've got the if logic, but it's not easy to use, right? Like it is with a regular imperative language. So that's why I think something like CDK, I'm really excited to actually be able to use it properly, because then if we're doing these components in dev and a slight difference in prod, then you can do that using a imperative language, which is far easier to do and also read. Some of these I don't want to say the word hacks, but some of these methods, they've got the imperative constructs into these declarative languages. They work, but they're not the nicest to read and they're not the nicest to use. So that's my personal feeling on it. So I understand why we need declarative constructs for infrastructure as code. So you've got the reconciliation loops, and this defines the state. But creating that defined state is where things like CDK and imperative languages are really powerful. So you use the imperative language to generate your declarative definition, I guess, something like that. Have you leveraged CDK for Terraform? I don't know. It was generally available. I don't know if it's out of beta yet or no. Okay. Listen.
Yeah, I think the thing with CDK is that, it's like you work with constructs, which are, further abstracting the underlying CloudFormation away from, say, the developer or the one writing the infrastructure as code. So it's like you have your low-level constructs, which are just CFN resources. I could clearly define an IAM role, for example, that I want to attach to my Lambda for my Lambda executor. But I mean, CDK also has high-level constructs, which are more of a CDK library, where I can tell it specifically within one call of one of the constructs, I want to create a Fargate load balanced ECS task definition, and that looks like 8 lines of code, where it gives me my application load balancer. It sets up the security groups, the underlying ECS service, its task definition, You can expand upon that, but like it just creates so many of these resources, and it's just so powerful. There's little gotchas with it though that like, I want to dive into it, maybe modify the underlying security group or something like that. Where, I don't know, it's interesting. It's kind of putting more of the infrastructure in the hands of developers. Is the way I feel with CDK. Definitely a fan of it.
I was actually going to ask. So when you get this advantage of these high level constructs, which build a whole bunch of infrastructure for you, do you have the flexibility to change that, or is it kind of opinionated and set in stone?
Yes, you typically do. You can typically dive into the underlying resources, and I've seen this most visibly with TypeScript, mostly because I can run in VS Code. I can do a debugger. I can then attach to the underlying object and see what aspects are a part of that object. So I could see that like perhaps I'm creating a security group. So I could call like this node.security group and modify the underlying like inbound and egress rules if needed. I have found some difficulties with doing that, and sometimes I do kind of get pigeonholed in. So I end up building out like that's a prime example, was like a ECS Fargate, load balance task definition, I believe is the construct. I might be butchering that a little bit, but those are ones I typically build out separate resources for, because of that underlying issues that sometimes I think some resources are inaccessible to modify.
So that's interesting. One thing that's similar in a way to CDK insofar as having those high level constructs, I've been using. There's lots of modules out there for Terraform, right, that will create all those dependent resources. So they do that high level abstraction. One that I've started using a bit is the Amazon EKS blueprints for Terraform. So they have a lot of good patterns and ready to go modules. You basically say, give me an EKS cluster, and they're doing all of the encrypt etcd, do your ingress, egress, all of the default modules, and it's all done for you rather than you having to go in and define each thing. So the similar idea that you've got those high level constructs in an easy to consume fashion.
So do those Terraform modules allow you to easily, do they have like the escape hatches, if you will, right? So if you do need to modify some of those lower level pieces, is that easy to do? Or
in my experience, I've seen that they are.
It depends. There it is. The classic architecture line.
This was my favorite mug. This was my favorite mug when I used to work in the office and we had meetings. It's like, it depends. Anyway, it depends. It depends on how the module was written, right? So if they've allowed you to, if they've created pass-throughs for various resource parameters, then sure, you can set that in your high level construct and it'll filter through. But sometimes they don't, and then you're kind of stuck. You can either create an issue for them to add that feature, or contribute, or fork it and do it yourself, or do away from that part of the module and re-implement that yourself. There's options. Typically, to date, I've found that certainly for those particular ones, the Amazon EKS blueprints, they've been pretty solid and flexible.
Yeah, I've seen specifically with some of the Cloud Posse ones, I've certainly had to go ahead and write my own modules because I was unable to configure certain aspects of theirs. It's like, yeah, I could have forked it, but then at that point, I need to change one thing, and it's going to be a fork that's not maintained. And that was more of a related thing that was outside of
quite often. If the particular module you were using is well written, if you're finding some deficiency, sometimes it's because there's maybe a different way you should be trying to implement your project, right? Sometimes people perceive a deficiency in some upstream standardized thing, and really you're doing it wrong. So do it right, and it'll work perfectly. So, and I think trying to force your preconceived way of doing it and then resulting in having having to fork or clone code bases, which you then have to maintain, that's going to be way more work than just adjusting your approach, using the accepted standard way, and being able to use like fully maintained packages.
Yeah, that is great advice. I'd just like to reiterate that. Right. If you find yourself like, oh, this is missing, right? Like an offering from a vendor or a package, it's like, oh, if they just did this, it's good to just take that step back, like, well, why aren't they doing it? Right. It's usually, okay, you don't need to, there's a better way. Yeah, I really like that advice.
And sometimes there's a legitimate hole, right? And it needs to be fixed. I mean, I'm not saying that isn't the case, but a lot of the time you've got to have that ability to like be introspective, look at what your solution is, and be willing to adjust it and learn new things. I mean, this whole industry it feels like it's a learning playground for those who love to learn, but there's always something new to learn, and quite often learning something, an alternative or a new approach, will solve a lot of problems, because you're probably not the first person to have some particular problem you're trying to solve.
Certainly. I think Joe Coleman joined us. I think he might have a question.
Yeah, I just didn't want to interrupt you guys. You had a good flow going. But yeah, we got a question here in the chat. How are organizations using infrastructure as code where they don't have public cloud? And does that not change their infrastructure setup often? This is an example, they might spin up new applications once every, in 6 months. So.
I think that's interesting. I think it depends. It's like, what if you're not in a public cloud? Is there an API that allows you to provision those resources? I'm not too familiar of frameworks outside of public clouds. I don't know if you all have.
I mean, you can use
VMware has
you can use the serverless SAM, I believe it's called, for AWS. So if you're like looking to get into the cloud, you could still write infrastructure as code, and you can kind of test your infrastructure, such as like serverless components, Lambda, API gateway. You can do like, I believe it's like SAM local is the command that you can run. And it's kind of like mock endpoint services for your infrastructure as code. So, I mean, it could be maybe used as like a proof of concept of, does my API gateway work if I'm like looking to move to AWS? But yeah, I think you bring up a good point there, Tom, is like, is there, APIs for whatever you want to, write for? Terraform might be something, I guess, because there's like 1,000 providers. Perhaps you can use Terraform if you're not on like maybe one of the public clouds or something. Yeah.
I have seen. I know that in the early days when it was all VMware, there were definitely APIs available. So if internally you could leverage the APIs. When I last dealt with that, there weren't any like common platforms for doing that. So it'd be like someone internally scripts that API. So that's not very matured, right? So, but I do believe Terraform has a lot of providers for, like, you've got your providers for your Cisco switches and F5 load balancers, your VMware. So
yeah,
not necessarily just looking at constructs that we know about in the cloud, like the cloud supported products like API Gateway, but you can codify the physical devices you have on premises. And then there's also taking cloud technologies, or typically cloud-based technologies, to your on-premises data center. Like one example of that being like OpenShift, right? So you can for those who aren't aware, OpenShift is basically another variation on Kubernetes, and it's designed that you can just install it in your on-premises, and it's like your on-premises cloud. Then you'll have all the same constructs. So yeah, there are ways to do infrastructure as code on-premises, but it's not as standardized as in the cloud. Right, Tom?
And also, there's not as much benefit, like you say, the infrastructure isn't changing as much. When you go to the cloud, it opens up so many more possibilities that you didn't have when you're on-prem, such as DR. So you can easily replicate that production environment in another region, which it's hard to do. You could have it on-prem in another location, and also just within the same region, not even DR. If you want to test different changes to a production environment. The infrastructure as code allows you to spin up exactly like production for an hour, run tests, but that's really hard to do in an on-prem environment where your resources are very limited, right? In the scope of what you're using it for in production, where you can't just double your capacity in an hour and then take it down. So there's a little less benefit, I would say, when you're not in the cloud.
Yeah.
I think that really touches on one of the main one of the major benefits of the cloud is that scalability, right? You can scale down to 0 and not pay for it. You could scale up to 1,000 instances just as you need it. Now, depending on the size of your company, that's not feasible, right? If you've got 1,000 instances, sure, you can scale up to 1,000 instances, but you can't scale to 0. You're always going to be paying for those servers. So if you're a big enough company and you've got enough spare compute, then you can use some kind of on-premises cloud to help share that around. But for the smaller companies, you need to provision for your maximum, which is what we're getting away from with the cloud. So you lose that benefit. Sometimes you have to be on-prem.
I know we are kind of getting close, but I kind of wanted to touch on, you mentioned Kubernetes, Tommy.
Yeah.
I mean, I think we have an internal joke that like Kubernetes is a cloud within a cloud often, but like you could certainly, you could run Kubernetes locally if you really want to provision your own cluster. And I mean, you could use things like Helm then in that case, right, Tommy? That would allow for you to configure your pods.
Yep. So yeah, I guess we didn't get a chance to talk about Helm at all. So after that, after we got that third attempt at the landing zone, the vendor that we worked with actually suggested we go the Kubernetes path. So I was like, oh, it's just an orchestration engine. And then I started learning about Kubernetes, and it's just an orchestration engine is not the right thing to say. It's a cloud, right? It's everything. And going into that journey of learning Kubernetes was heavy. And to be honest, most of my focus since then, for the last few years, has been more on the Kubernetes side than specifically playing with like stuff directly on AWS. So yeah, Helm is definitely one of the ways to deploy things on Kubernetes. There's three main ways, right? You can deploy the manifests directly. So every component in Kubernetes, every application component in Kubernetes has a manifest that defines it. So you could define them manually, but then editing them is a nightmare. So we use templating engines. Helm is the templating engine. So, and then we've also got things like Customize. And I feel like Helm, Customize, and that kind of stuff is probably a discussion in its own right as well. But certainly Helm is one of the good options for deploying your application in a consistent way on Kubernetes.
At a high level, how do you compare it, right? I haven't used Helm much in Kubernetes in that regard. How do you compare it to like a traditional cloud formation? Like I know like some people say it's more of like a package manager, right? So is it like your, package.json file, like NPM, or is it, or is it more like traditional infrastructure as code?
It can be a bit of it depends. It's a mix. So there's, in the Helm charts that I've been working on, there's definitely two sides to it, right? So that you definitely got the infrastructure side. So you've got like ingress objects, service objects, persistent storage, and the pods themselves. This is all infrastructure at the end of the day, right? This is getting packets to your application and back out. Like that's infrastructure. But then you can also configure the application itself. Like you might pass in configuration files for your application, and that's going to be a different configuration file or environment variables. However you're passing the configuration in, that's going to be different on different environments. So it needs to have some control over that as well. So it's both. So yes.
Would you use CloudFormation with Helm, or does it,
I think you could in a way. I mean, CloudFormation could be used for creating the cluster, right?
Yeah, I haven't thought about it before, to be honest. Because at the end of the day, when you are deploying Kubernetes resources, you are now talking that whatever tool you're using to deploy it is talking to the control plane of Kubernetes. So whereas with your CloudFormation, it's talking to the AWS control plane, the AWS API. At some point, your your EKS cluster is up and it's ready to start deploying things. To deploy things on there, you're no longer talking to the AWS control plane API. You're talking to your cluster's control plane, and you're saying deploy this pod. So I don't know if CloudFormation natively has any constructs to allow you to allow the CloudFormation service to talk to your EKS control plane. Maybe it does. I haven't looked at that, honestly. But you could certainly do something like create a Lambda function in CloudFormation, and that Lambda function would have the tools on it, or it could do what's needed to provision that into Kubernetes. Or what we're more typically moving towards now is more of the GitOps type workflow, where you have something running that does that consolidation loop. So you might have your Helm charts and stuff in a repository, and then something's like applying that to the cluster. So an example of that is things like Argo CD and Flux. So they're basically using that reconciliation loop to take your Kubernetes manifests from your repository and apply them to the server. So that's just happening automatically. So CloudFormation, I don't know. I'm going to be looking at that. You can trust me, I love to learn. So I'm going to be like, I'm curious now. So I'm going to go research that. But interestingly, we talked about using Helm from CloudFormation or deploying Kubernetes things from CloudFormation, but there's actually an interesting thing that I've started looking at. It goes the other way. So right now, let's say we deploy an application with Helm, and let's say your application needs an RDS instance, Route 53 DNS entry, and some other AWS managed service resources. Now, there's things like Crossplane. So Crossplane is it's an operator, essentially. It runs inside your Kubernetes cluster. So now, in your Helm chart or your Kubernetes manifest, you define that I want a Route 53 DNS entry in your Helm chart, and then Crossplane will go out and provision that infrastructure for you. So now we're doing everything from Kubernetes, if you like. So that's actually, it wasn't on the list of things to talk about, but it's another interesting infrastructure as code option, because you're still defining your cloud infrastructure from code, but now it's coming from, it's packaged with the application code, or with the app. When I say application code, I mean like the Helm chart. So how to deploy the application in Kubernetes. So there's more new things.
Yeah, that's where I always get hung up. Like you said, you could do it different ways. And that's, I work with a lot of different customers, and some have it set up where, it's Kubernetes is controlling the load balancer settings and things like that. And it's hard to tell where things are being controlled and what's going on. Because, there are so many options, but yeah.
And that's the thing about this industry right now, is there's so many different dots that can be joined in different ways. And having that picture of available options in your head, that can be challenging. Right? It can be quite enjoyable if you've got the right kind of head. I certainly enjoy that. Look at all the different options and then think, well, this one actually makes more sense. Let's go that route. But yeah, it's an interesting space and getting more complicated. But sometimes that complexity helps us build in simplicity for the user. Like the user could be a developer, right? Or whatever. But sometimes all this complexity behind the scenes, like Kubernetes, is complicated, but it makes deploying easy. So I could waffle on about this stuff all day long as well. So I'll stop.
Same here.
No worries. I mean, I really appreciate your insight into, everything you provided here today. We are at time, so I want to take an opportunity to thank all of our listeners in today's, for tuning in today for our episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable. And we'd love to have you join us again next week where Jason Brown is going to continue his series on serverless architecture, and we'll be expanding upon event-driven architecture. As always, the episode will feature expert guests and interactive conversation, so be sure to tune in.